All right, so this is part 2 of section 6.4. We're going to talk about how to write this in simplest form. I know that we can rationalize it, but there's a couple of other ways we can do it as well. Okay, the problem with this is that we have different indexes. Okay, and, if I try to rationalize it, then I end up multiplying a fourth root by an eighth root on the top, which you can't do. So what we're going to have to do is change it to exponent form. So the top of this will be x to the 3/4. The bottom of it is x to the 2/8. So following your rules for exponents, when it's a division problem, it says keep your base, because I have the same base, I'm going to keep it, and then do the top exponent minus the bottom exponent. Well, to subtract fractions, you have to have common denominators. So I can reduce this one so that it will be 1/4, or I could change the first one to 6/8. I'm going to reduce the second one. So 2/8 reduces to 1/4. 3/4 minus 1/4 gives me 2/4. You must reduce that so that you've got x to the 1/2. And then, because the problem started in radical form, your answer must be back in radical form. So your answer is the square root of x. Okay, so let me go back and fill in my other steps. Step 1 was to change it to exponent form. Step 2, keep the base. Subtract the exponents. Step 3 would be to simplify the fractions or get common denominators. Okay, and then we're going to finish our subtracting. And last, step 5 was correct form. And for the correct form, answer must be in the same form as the original problem. Okay, and here it's also typed for you down here. I wasn't paying attention. I could have skipped that part. Anyhow, your answer must be in the same form as the original problem. So if the problem starts out in radical form, you have to finish in radical form. If it starts out in exponent form, it must finish in exponent form, no matter what you do in between. All right, next, we're going to take a look at a shortcut for this one. Okay, same problem that we just did, but what I want you to notice here on the bottom is that exponent and index are both divisible by 2. So if you go ahead and do that, divide both of those by 2, that's going to give me the fourth root of x to the first. And now they have the same index. Okay, and if you think about it, over here, when I reduced 2/8 to 1/4, that would have given me the fourth root of x to the first. Okay, so to finish doing it this way, because they are both fourth roots, I would put it together as one big fraction, or one big radical. Simplify that, so I get the fourth root of x squared. And now, again, my exponent and my index are divisible by the same number. So when I do that, I end up with the square root of x to the first. That is the same answer I got doing it the other way. Not every problem can be done this way, but if you're paying attention and it can be done that way, saves you a little bit of time. Okay? Keeps you from working with quite so many fractions. So here's your little side note, okay? You can only use this shortcut if the exponent and index are divisible by the same number. All right, so let's do a couple of these. Okay, some of them are multiply, some of them are divide, but they have different indexes, so we cannot work with them in radical form. So for this one, I have a square root and a fourth root. Nothing simplifies, so let's change both of those to exponent form. Okay, this is a multiplication problem. My bases are the same, so I'm going to keep my base and add my exponents. The problem with that is my fractions don't have a common denominator. So out here to the side, I'm going to add 1/2 plus 1/4, getting a common denominator. Multiply this by 2 to get 4, so multiply the top by 2. And when I add those fractions, I get 3/4. So I have 3 to the 3/4. Put it back in the correct form. So that's going to be the fourth root of 3 cubed. If you have a number to an exponent, to a power, go ahead and simplify that. So I end up with the fourth root of 27. All right, moving on to part B over here. Okay, I have a square root divided by a cube root. I can't work with those that way, so let's change them to exponent form. Oh, that's a 2 on the bottom, that's 1/2. The bottom one is x to the 2/3. So the rule says when you have a division problem and the same base, keep your base, top one minus the bottom exponent. So now I have to subtract those fractions and get a common denominator. So 1/2 changes into 3/6. 2/3 is 4/6. Well, that gives me a negative 1/6. So this one's got a little bit of extra to go with it. Oh, hang on. This is all wrong. This is not x to the 1/2. My exponent is 3, so it should be 3/2. Sorry, guys. It happens. So when I change this to a 3, 3 over 2 becomes 9 over 6. So I end up with 5 over 6. Well, that takes care of my negative problem. So yeah, we had a little bit of an issue, but it works out better for us in the long run. So my answer, well, let's try this first. It's going to be x to the 5 over 6. Put it back in radical form, and it's the 6th root of x to the 5th. There's your answer. Okay. Even though we had a mistake back in here, it's still better than dealing with that negative fraction as our answer. Okay. All right, moving on to part C. I have a 7, or a square root of 7, and a cube root of 7. Let's change them to exponent form. This one really is to the 1/2 power times 7 to the 1/3. So keep my base, add my exponents. I need a common denominator. So 1/2 plus 1/3. This is 3 over 6 plus 2 over 6 gives me 5 over 6. So 7 to the 5 over 6. Put it back in radical form. And because this is going to give me such a large number, if your exponent is more than, say, 3, I'll let you just leave it. Or if you want to multiply this out, you end up with the 6th root of 16,807. I have just a couple more. Okay, this is similar to some examples we did in the first video, I believe. Let me find them. Yeah. It's similar to this example, but this one has variables. This one deals with numbers. So let's talk about how to do this. Okay, this is 16 to a negative exponent. So what I have to do is fix that negative exponent first. I'm going to move the 16 to the bottom of the fraction. It will make my exponent positive. So then I know that 2.5 is the same as 2.5, which is 5/2. So what I've got is 1 over the square root of 16 to the 5th, but I don't want to have to go to that huge number and then try to take the square root of it. So what I'm going to do is use that rule we talked about earlier, and I can put the 5 out here. So now what I'm going to do is I'm going to take the square root of 16 and then go to the 5th power. So this will give me 1 over 4 to the 5th, which is 1 over 1,024. All right, part B. This time my exponent isn't negative, but my number is. Well, that's okay. You can have a negative number. You just are not allowed to have a negative exponent. So I'm going to go ahead and put this in radical form because my brain works better with it there. So I'm going to have the 5th root of negative 32. I can put my 4 inside, but that's going to give me a really big number. So I'm going to put my 4 outside. So that will give me the 5th root of negative 32 is negative 2 to the 4th power, will give me 16. Okay, and there is a way to do that in exponent form. I'll do this one that way. And then if you have questions, you can let me know in class. What you could do, since my denominator here is a 5, see if you can rewrite negative 32 as something to the 5th power. So negative 2 to the 5th power is negative 32. But then all of that is to the 4/5. When you have a power to a power, you multiply. So what I end up with is negative 2 to the 20 over 5, which is 4, gives me 16. Same answer, two different methods. This one looks shorter, but it's only good if you know how to rewrite negative 32 as negative 2 to the 5th. Okay? Either way will get you there. All right, so for the sake of time, I think what we're going to do is skip on down to problem B, and we will talk about problem A in class because it's a little more complicated and you need to be able to ask questions about it. So here's the thing. Everything in this parenthesis is to the negative 3/4 power. So what I'm going to do is I'm going to write them separately. Then, when I take and multiply these exponents together, I'm going to get a positive. Y will be to the 24 over 4, which is 6. But my 16 will have to go to the bottom because it has a negative exponent. So y to the 6th over, let's do the 4th root of 16. And I'm going to put my 3 outside. It gives me y to the 6th over 2 cubed. It's y to the 6th over 8. All right, so there we go. We'll talk about all the rest of it in class.